Now, you have a question here that the stone is projected upward at an angle of 30 degrees to the horizontal from the top of a tower of height 100 meters and it hits the ground at a point Q. If the initial velocity of projection is 100 meters per second, calculate the figure 1 maximum height of the stone above the ground, the time it takes to reach the height, time of flight, and horizontal distance from the foot of the tower to the point Q. Neglect air resistance and take G is equal to 10 meters per second square. Okay, so I think auxiliary distance from the point Q, from the foot of the tower to the point Q, neglect air resistance and take G 10 meters per second square. So this question you have to what? You have to draw out something out. But before you draw something out, let's know some facts that you need to know about this topic. Now, if something is drawn upward under this, that is going against gravity, so your gravity will be negative, and that thing to throw upward has your U initial velocity to be maximum and the V to be 0 at that highest point. So when it reach highest point, the highest point that is maximum height, your V is automatically 0 at that point. Okay, now if it is coming downward, if you want to throw something downward, your G will be positive because it is going towards gravity, and U will be 0 because at the point of dropping it, the initial velocity is 0, and your V will have some value because it's going to reach the final point, which is ground. Okay, and that's it. And also, your equation of motion will be useful. S is equal to ut plus half at square. Under this gravity, you change your x to this and gt square. Your a is g, acceleration is for horizontal and g is for vertical. So when it is upward, you know your g is negative and you change it like that. So you have your v squared is equal to u squared plus 2s. Under equation of motion, it will be v squared is equal to u squared plus 2g h. So under this one, and you have I think is equal to u plus 80. So it will give us v is equal to u plus gt, and you apply all these things. So these are the facts you are supposed to know when the subject is throw upward or downward or any part. But if you now need it, if it include an angle, then your t either time to go upward or come down is u sin theta over g. For total time of flight, it will be 2u sin theta over g. In other words, it is 2t. Okay, so if you know your t, and this thing come back to the point of throw again, let's say it starts from here and come back here, you see the same line at the same point, so it is 2t. So, and also your maximum height h will be u square sin square theta over 2g. Okay, and your range is u square sin 2 theta over g. We have maximum range. I said this can come to when the angle is 45 degrees. Okay, when the theta is 45 degrees. When theta is 45 degrees. Okay, so don't make the mistake. So that's the basic information you need to know about this thing. So we are going to draw this thing out and do the calculation. Okay, and also look at this thing. Also that distance from the foot. Let me add one question to this thing. Let me see, you want to find range and also total time. So this thing, you are going to get it along the way when you are doing it. So let's draw the diagram out. Now what information say? A stone is projected upward. So the stone is projected upward at an angle of 30 degrees to the horizontal. So okay, from the top of a tower of 100 meters. So the tower is 100 meters and they project the stone from the top of it. Okay, so they are not projecting it from the ground, they projected it from the top of the tower. Let me use the other page to make it clear very well. So let's say this is the tower. Let me just draw something like a tower so that you get what I mean. So this is the tower, 100 meters. So 100 meters. And the objects, what information do you have? They said it's projected upward. So it's projected upward at an angle of 30 degrees to the horizontal. So you project it upward at an angle of 30 degrees to the from the top of a tower of 800 meters, and it hits the ground. So you don't. So I said from the horizontal, the angle 30 degrees to the horizontal. So in projectile motion, the angle or to the horizontal is called the angle of projection. Okay, so the angle of projection. And let me just give you the basic facts you need to know about this stuff. Look at this. This is how a projectile looks, something like this. So it's going to have horizontal something and vertical something here, and if you show something up like this, this is your U, general U, the velocity of projection. So it will have Y component and X component, and if you check this thing out, the angle of projection is here, and this look like a triangle. So if your U is here, UX is here. If you want to find UX with respect to theta, it will give you U cos theta. Like this, look at it. Theta is facing here, but theta with respect to this one, UX is adjacent to it. So US is adjacent, and U is hypotenuse. So between so and K, which one is having adjacent to hypotenuse? It is cos. So you see your cos theta is adjacent over hypotenuse, and US will now be what? U cos theta. And if you do for UI also, UI is, UI will be here, and it will be what? Formatted like a vertical, and that is what? Opposite to the angle. O, UI, and H is U. So which one has this sign? So it says sin theta is equal to UI over U, and UI is equal to what? U sin theta. And that's how to get this. So far the angle is to the horizontal. This is what you are going to be using your U vertical and U horizontal, and you cannot use the rest of the horizontal in vertical calculation. That's wrong. Okay, so what are we doing now? So in your horizontal, this thing A is equal to 0, acceleration is equal to 0, so there is no acceleration here, and this US is constant throughout. As you throw something upward like this, it has horizontal velocity and vertical. So the velocity is the horizontal is constant, but the vertical is not constant. That is why we are going upward. It is coming from maximum something and then end up at 0. So it's not constant, right? It's decreasing. Okay. So what else? Now I think this is what you need for here, and you see this one from the point of this one to the point of this thing is what we call your range. See the same line. It comes here and here, so this distance here is your range. So here, and the maximum point height is here. This center point that is highest is called maximum height. We denote it with capital H. Okay, and what else do we need? And that's and the time to reach here is the time upward, and the time to come down to this point is the time downward. So if you add the two together, that is your what do we call it? That is your total time of flight, and that's how we know that. So now let's do our diagram. So the stone is projected upward at an angle 30 degrees to the horizontal from the top of a tower of 800 meters. Don't forget, from this point to this point is 90 degrees. So if you say they give the angle to the vertical, which is 60 degrees, you can quickly subtract it from 90 degrees and get your answer here. Okay, so now the stone is projected upward at an angle of 30 degrees to the horizontal from the top of a tower of 800 meters. So we have done the 100 meter high, but the stone is now projected somewhere here. And just draw something like this. Okay, just draw something like this, so you get it like that. Let me just draw something, because this thing is here, it's at this top somewhere here, and the stone is coming like this, and they tell us it reached the ground at point Q. So forget, they said it reached the ground at the point Q. It hits the ground, not the top of the wire again. It go down to the ground at the point Q. So the person that is projecting this thing is at the top here, and see this thing hitting up here is what this is the highest point, right? So that's where you are going to find your H, right? And they said the angle is what? To the horizontal, but the thing is projected like this. Okay, now be going like that. So you're gonna see something very similar to that. And they say that if the initial velocity of projection is 100 meters per second, calculate the maximum height and velocity. So they're telling us this one is 100 meters per second. The u is 100 meters per second. So you are going to distribute it to the vertical and the horizontal component. So you get to the vertical. So vertical stuff here. That's the horizontal components. So now for h, you are going to use horizontal stuff for it, and this one horizontal. We are going to use vertical component for h because height is vertical, and that's how to do it. Now, what they ask for? Calculate maximum out of the stone above the ground. Now, because this thing involves angle, we are going to use what? H is equal to u square sin square theta over 2g. Okay. So, but we don't know what you do now. So now, look at this stuff. You are going to use x. X is what? What did I call you earlier? U cos theta. What did I call ui? U sin theta. So if we need any of these two, just take your u 100 cos angle and you get it. Okay, now but our h now is what? Our h is u squared sin squared theta over 2g. So now it's u squared. Don't make a mistake. It's u squared. The u is 100, so 100 squared. And this sin theta means what? What is sin angle? Sin 30 is here. And you squared it like this. That's how you use this square here. And 2. And your g is 10. So that's what we are going to do here. So now, let's use our calculator. So 100 squared will give us what? It will give us 1 to the 0 to 40, 10,000. And sin 30 is what? 0.5. And 0.5 squared will give us what? It's not 0.25. Should give us 0.25. So that's 0.25. And this one is over 20. So if you should cancel some 0 from here and cancel 1 0 here, you have 1,000 here and something. And you say 2 here, 1 and 2 in 10 will give you something like what? Let's say 500. So automatically if you cancel 20 here and 20 in 100 will give 500 straight. So we have 500 times 0.25, and what is 500 times 0.25? And that will give you 125. So I hope you don't make mistake. The height here is 125. The height from this point of projection to this maximum height of projection, not the height to the ground. If you want to know the height to the ground, you add this 125 to this 100 and you get the height to the ground. So you get. So this is what they ask in the question. Maximum height of the maximum height what? Maximum height of the stone above the ground. So you see, the question is asking for the maximum of the height of the stone above the ground. So they're asking for above the ground, but this one we got is from this projection to this top. So you're going to add 100 to this one. So the maximum height to the ground will be what? Height to the ground is what? 125 plus 100, and that is what? 225 meters. You see, you have to draw. You cannot just take value inside this thing and be drawing all this stuff. So you get. So your diagram will guide you now. The second is the aspect the time it takes to reach this height. So it reached some height at this top here. So it reached the height here from this point. Our t for upward is what? U sin theta over g. U sin theta over g. Right. So what's our u? 100 and sin theta, sin 30 over what? 10. That is what? It is half, and half of 100 is 50, and 50 over 10 is 5. So the time to go up is the time to move from here to this top is 5 seconds. So if this one go from here to this point 5 seconds, then this part also will be 5 seconds. That's it. That's about your projectile motion. If it's at the same point to this top and from this point to that point again, the time is equal. Okay, now so you have gotten your that time, and that's called time of flight. Time of flight, you can just say your t is 2t, which is 2 times 5, and that is 10 seconds. Or if you disagree, you say 2u sin theta over g, and you get your answer is again 2u is 2 times 100 times sin 30, which is this, and over 10. Okay, this is 200 sin 30 over 10. So sin 30 is 0.5. This is half. Half times 200 is 100. 100 over 10 is 10 seconds, and we arrive at the same answer. So that's how to do that. And the next question asks, horizontal distance from the foot of the tower up to the point Q, neglect air resistance and other stuff. Now, horizontal distance from the foot of the tower. They're asking for a distance here. It's not that's not your range, Joe. That's not your range. Your range is here, this point to this point. And if you see something, you see this point is somehow bigger than this stuff, right? So let's say point here is point P or something like that. Let's say here is E. Let's just put some values here. Get something we are doing. Now, look at this stuff now. Very well. Your range, we need, if you want to calculate the range, to give you something like this time. Okay? But your horizontal distance, the full, you want to calculate all this distance, you're going to use what? The formula for this one, but you want to use this velocity to the horizontal and what? And total time to get this from here to here. From here to here, you need total time. And the total time is not here. It's not 10 seconds. This thing's move from here to this point. Okay? It's move from here. From here again to this point. Because we have to calculate the time here. Now we have to consider some equation of motion now. This thing is coming downward. So you already know G is positive. What is U is 0 and V is maximum. So we need time. We need to calculate total time now. From point here down here. From this point down here. From this point down here. So you have lived this 5 seconds. From this point down here, you have to calculate the total time. So your H usage is equal to UT plus half GT squared. Is the one we are going to use? So yes, we are going to use this one because this one will turn to 0. So now your height, total height is what? 225. Don't forget, because we want to calculate the total time from this point to this down. So use total height from this point to this ground also. Total time from this height to this ground also. So now your U is 0 according to what you have know about your downward motion. And you have your half and G to be 10 and T you don't know. So this is your 225 is equal to what? 0 here. Half of 10 is 5 and that is 5t squared. So you divide 225 by 5. And that's your t squared here. So what is your 225 by 5? It's 45 here. Okay, it's 45. It's 45 here. 45 t squared. So what is square root of 45? That is 6.71, and your unit for time is seconds, so you put it there. So this 6.71 seconds is all the time from here or down here. You see the point here down to this point, and that's very good. So and so if this point is to this point is 5 seconds, then say 6.71 minus 5 seconds will give you this point, and that is 1.71 seconds. So the time it takes from this point to this point is 1.71 seconds. Okay, so now what are we asked to find? So since we have gotten this to be 6.71 seconds, so we add the remaining 5 seconds here, making it 11.71 seconds. You getting? So 11.71 seconds is total distance. So we need this formula to use. So we say our R, Ux is what? U cos theta times total time, which is 0.7 seconds. What is our U? 100. And cos theta is cos 30 times 11.71. So that's what it's not range. Actually, we are looking for its horizontal distance. So we need all this stuff. The range is different here. The range is something up here. If the range is equal to the horizontal distance from science, but this one, the range is slightly smaller than this thing. Now, what do we need? Okay. Yes. Multiply. What's your cos 30? 0.866. And this one 0.71. So what is 100 times 0.866 times 11.71. That's a bigger number. So we have it will be 1004 points. What's the points? 0.1 meter. So that's the total distance. So you have gotten the total time taken now. Total time to be 11.71 actually, and we are getting the total distance. The total distance. Now I want you to find the range. If you use the formula for range, you get the formula for range is u square sine 2 theta over g. Right. So now u squared is 100. That is 100 squared, and sine 2 theta over 10. You multiply this 2 by that theta. This is what? 10,000 again. And this one is sin 60 like that. And sin 60 is what? 2 times 30 is 60. Sin 60 is 0.866. And G is 10. There are things you need to know offhand. That's them asking you. You are supposed to know them offhand. Sin 30 and cos 60. They give you 0.5. Sin 60 cos 30 will give you 0.866, and sin 45 cos 45 will give you 1.51, and sin 90 cos 0 is 1. No, this one is not 1, is 0.7071. Sin 90 cos 0 is 1, and sin 0 cos 90 is 0. So all this stuff you have to know them offhand. So you see, this and this add up to 90, 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 and this add up to 90. So they are complementary. So they add up to 90 together. So like that. Now 10,000 this one. So 10 here, 1, 10 here, 1. So we have 1,000 left here. And that's 1,000. It's 1,000 left here. Okay, it's 1,000 actually. Times 0.866. So what's that? I don't know what that is. So that's give me 0.866. That will give me 866 meter. 866 meter. This is correct. So that's the 86 meter. That's the range. Now it means the range is from here to here, or where it traces down here like this. So how do you get this remaining part? So don't forget the time for this remaining part is 1.71 seconds, right? And I said horizontal velocity is constant. Ux is constant throughout, right? Now let's do velocity is equal to distance over time, and the horizontal velocity is constant, so it's u cos theta that we are going to use for this. Then your distance you don't know, but your time is for this remaining part is 1.71 seconds. So you say your d is u cos theta times 1.71. What is our u? 100 cos 30 and what? 1.71. Cos 30 is equivalent to sin 60, and that's 100 times 0.866 times 1.71. So what's that? Times 1.71. You will get 148.1. 148.1 meter. So add this to this. What do you get? 148.1 plus 866. So you get 1014.1 meter again, which is what we get here. So that's how you do your question under projectile motion. It's not something hard to do. Once you understand the concept, the question under projectile, you must be careful, so you draw it out, and that's how to do this thing. So thank you.